Good evening, everyone. I am Samia Sultana from Department of Cloud Computing, GM University. Today, I am going to present my project on linear regression using Scikit-Learn. In this project, I have implemented a simple machine learning model that predicts student marks based on the number of hours they study. This project demonstrates the hours they study. This project demonstrates the complete workflow of a machine learning model, including data preparation, training, prediction, evaluation, and visualization. Linear regression is one of the most fundamental supervised machine learning algorithms. It is mainly used for predicting continuous numerical values. The model learns the relationship between an independent variable and a dependent variable using historical data. In my project, the dependent variable is the number of study hours, while the dependent variable is the marks obtained by the student. The goal is to predict the marks of a student based on how many hours they study. Simple linear regression works with only one input variable and one output variable. The mathematical equation is y is equals to mx plus c. Here, y represents the predicted output or marks. X represent the input or study hours. M is the slope, which indicates how much the marks change when study hours increase. C is the intercept, which is the starting value of the regression line. The algorithm finds the best fit straight line that minimizes the prediction error. Next is the libraries required. For implementing this project, I used four important Python libraries. Pandas is used for loading, managing the dataset. NumPy performs numerical computations. Matplotlib helps visualize the data and regression line. Scikit-Learn provides machine learning algorithms such as linear regression and tools for training and evaluation of the model. These libraries simplify the implementation and improve efficiencies. Next is dataset. The data set contains two columns. The first column is hard studied, which is input features. The second column is marks, which is the target output. Each row represents one student's study hour and corresponding marks. The machine learning model learns the relationship between these two variables from the data set. Next is the data preparation. Before training the model, the data set is divided into two parts. 80% of the data is used for training, 20% is used for testing. The training data helps the model learn the relationship between study hours and marks. The testing data is used to evaluate how accurately the training model predicts unseen data. Next is model training. After preparation, the data set the linear regression model is trained using the training data. During training, the algorithm calculates the best value of the slope and intercept to create the best fit line. The objective is to minimize prediction error so that the model can make accurate prediction for new data. Next is the data model prediction. Once the model is trained, it is used to predict marks for the testing dataset. The model takes the study hours as input and generates predicted marks as output. These predicted values are then compared with the actual marks to measure the performance of the model. Next is model evaluation. To evaluate the model, I use two important metrics. The first is mean squared error, which calculates the average square difference between actual and predicted values. A lower MSE indicates better performance. The second is the R squared score, which measures how well the model explains the variation in the data. An R squared value closer to 1 indicates that the model fits the data very well. The data visualization is this graph shows the relationship between study hours and marks. The blue points represent the actual data samples, while the straight line represent the prediction made by the model. Since model data points lie close to the regression line, we can conclude that there is a positive linear relationship between study hours and marks. This visualization helps us understand how well the model fits the data set. To conclude, linear regression is one of the simplest and most widely used supervised learning algorithm. It is effective for predicting continuous numerical values and it is easy to implement using Scikit-Learn. In this project, the model successfully predicts student marks based on the study hours. This project also helped me understand the complete machine learning workflow including data preprocessing, model training, prediction, evaluation, and visualization. Thank you for your time and attention. I hope this presentation provided a clear understanding of how linear regression works using scikit-learn.